Welcome my today's last session on the laws of electromagnetics 3. So in the morning we have discussed some laws of electromagnetics. In the morning we have discussed about today we have already discussed about the field, classification of field, Coulomb's law vector form, Gauss law in vector form, Ohm's law, continuity equation, Biot-Savart's law. After this we have discussed in our first lecture. Ampere circuital law, Lorentz force, Newman's formula, Faraday's law and Maxwell's law I have discussed in my second lecture. The third lecture is about the Maxwell's law, modified from Maxwell's law in the free space Poynting theorem, and the Laplace and Poisson's equation is in the third lecture. So this total law of the what is the behind of the electrical engineering we will discuss in my three laws. The first, second and third. The first law, second lecture and third lecture is comprises of all the laws. So today already we have discussed the basics, and the first few laws is about the electrostatics and the conductors and the behavior of the conductors. The second lecture is basically electromagnetics for the static field and time varying field. My third lecture is totally based on the time varying electromagnetic field, time varying electromagnetic field. So I will discuss about the three lectures. The third lecture is basically on the electromagnetic field. So this is my today's lecture. Now we will start with the Maxwell's equation. Already I discussed, my last lecture was ended with the Maxwell's equation. Again we will revisit the Maxwell's equation. So what is Maxwell's equation? Maxwell's equations has the four equations that together form a complete description of the production and interrelation of the electric and magnetic field. The physicist James Clerk Maxwell in the 19th century, based on his electromagnetic fields rule, first it gives the four equations which obeys the experimental law. The statement of these four equations are: first one, electric field diverges from the electric charges and expression of the Coulomb's law. So from the modified Coulomb's law, we got the electric field diverges from the electric charge. If there is an electric charge, there are some electric field which diverges from the positive charge, and which will give one expression of the Coulomb force or electric field intensity. And this law, and the second law is still there is no isolated, the statements there are no isolated magnetic poles, but Coulomb's force acts as the poles of a magnet. Though there is no non-polar magnet is not practically visible, but Coulomb's force acts between the poles of the magnet. Electric fields are produced by changing the magnetic field, and expression of Faraday's law of if there are the electric fields are produced by the magnetic field. If the flux is time varying, there is the electric field, and this is known as the Faraday's law of electromagnetism, Faraday's law of induction. And fourth law is about the circulating magnetic fields are produced by the changing electric field, and this is called the electric currents. Maxwell's extension of Ampere's law include the interactions of the changing field. So the four laws we can write as: the first one is the modified Gauss law. Second one is the modified Gauss law in magnetic field. The third law tells about the modified Faraday's law. And the fourth equation tells about the modified Ampere circuital law. So we have already 4 equations. Now if we want to write it in one page, we can get there are 4 equations. Thus we can write the equation from the differential form or point form, and we are writing in the integral form. So we can find 2 equation is for the time varying field and 2 equations are for the static field. First we will tell about the 2 are for the static field. Now first equation is for the time varying. I can write with the another one. This is for the first is the Gauss law. What is the Gauss law tells? Integration of a surface integral of d dot ds is equal to surface integral of rho v dv, and we can also write grad dot d is equal to rho v. So this is we get from the Gauss law. The total derivations has been discussed in my previous lectures. Then magnetic charge for this. So this is for the electrostatic field. So this rule is for the electrostatic field. Next law is for the static magnetic field. Static magnetic field. The third law is tells about the grad cross H is equal to J plus del D by del T. Grad cross H is equal to J plus del D plus del D, and H dot dl is equal to I del D by del T into ds. This is the modified Ampere circuital law. Grad cross H tells that it is a time varying magnetic field. Grad cross H tells about a time varying magnetic field, and grad cross E tells about the time varying electric field. And what we got? Grad cross E is equal to minus del B by del T. It is the modified Faraday's law. In this 2 equation, you can find the correlation of the electric field and magnetic field and electric field. That's why these are about the electromagnetic. These rules tells about the electromagnetic field. So this is the Maxwell's law in a glance. So Maxwell's law has the 4 equations. Now we will discuss about the electromagnetic equation in the free space. We can also tell this equation, and before that we will discuss about the Maxwell's equation in free space. We will discuss in the Maxwell's equation. For this we can tell Maxwell's equation in the free space. So in the free space there is no current, because current can also flows in the conductor. The amount of the displacement current is very, very small. So current means the conduction current density or current density J equals to 0. The current density J equals to 0 for the electromagnetic wave equation. Current density in the free space is equal to 0. Again, we will discuss about the volume charge distribution, and volume charge distribution, if there is no current means there is no charge, because we know that the charge, what is the meaning of the volume charge distribution? Volume charge distribution we write by rho or rho v is equal to q by unit volume. So actually if there is no current in the free space, then rho v is equal to 0. What is the third equation? The permittivity is equal to epsilon is equal to epsilon naught, and permeability of the medium mu is equal to mu naught. So we can write from the Maxwell's equation. For the Gauss equation, we got Maxwell's first equation, we got grad dot d is equal to rho v. What is d? D is equal to epsilon into E is equal to rho v. So grad dot E is equal to rho v by epsilon. So as the first law that rho v is equal to 0, so we can write grad dot E is equal to 0. So this is the modified Maxwell's equation in the free space. What is the modified Maxwell's equation in the free space? Grad dot E equals to 0. Next, we can discuss about the second law. Second law is the unchanged. Actually, this is the unchanged. Grad dot b is equal to 0. Grad dot b means, what is the meaning of the grad dot b? Grad dot b means the grad of b. B means the flux density equals to 0. Now we will write the grad cross E is equal to minus del B by del T. This is also unchanged. But we know the modified value of the grad cross H is equal to, the third equation tells about the what the third equation tells? The third equation tells about the grad cross H is equal to J current density plus JC, and we can write grad cross H is equal to J conductor current density. Current flows through a conductor, and we took this is 0. So 0 plus JC. JC, what JC is the displacement current density. What is the meaning of the current density? The current flows through the dielectric media. So as we know that the free space is a dielectric medium, so JC will be present there. So we can write grad cross H is equal to JC. Now what is the value of the JC? JC we can write as, how we can calculate the JC? JC is nothing but the current through the capacitor. So we can write is equal to DIC by ds, current through the capacitor divided by surface area. So what is the DIC? We can also write as, what is this? Current in a capacitor is equal to C dV by dt. We can write C dV by dt, or we can write as d by ds epsilon a by d, epsilon a by d into dv by dt. So we can also change it as the A. What is the meaning of A? A is the area. So area means length into diameter. So area may cancel out, and we know V is equal to E into dl. What is the voltage gradient? Voltage into the thickness of the thickness of two parallel path. So what is the V by dl? V by thickness or V by d? V by dl or V by d into d. So what is the meaning of the V by d? V by d nothing but the E. So ds, or ds means the area, so we can write it A also, current area. So dA cancel out, so it is coming as V by d is equal to E. So d by dt, d by dt, dv by d is equal to E. Epsilon into E. What is the meaning of epsilon into E? Epsilon into E is nothing but the D. So Jc is equal to d by dt. So what we got here? We know current Jc is equal to current by area. Now what is the meaning of the current in a capacitor? C dV by dt. Now what is the value of C? Epsilon A by d into dV, or we can just write here current by area. No need of writing di by dt. We can write here I by A. Then it will be easy for you. So this by A. So here C is equal to epsilon A by D into A. So A cancel out, we got d by dt, epsilon V by D, V by E is equal to D. So V by D is nothing but the potential. So we can write here epsilon into E by dt. So epsilon into E is equal to D. So the current grad cross H is equal to Jc by d by dt. Now in the air, the conduction current is 0, so grad cross H is equal to del d by del t. Why we are writing the del d by del t? Because flux is a three-dimensional thing. Now we will discuss the skin effect. What is the meaning of the skin effect? The phenomena arising due to the unequal.
No problem. This is land effect.
I think.
I'm just speaking to James like that.
So, now we will discuss about the skin effect. The phenomena arising due to the unequal distribution of current over the entire cross-section of the conductor being used for long-distance power transmission is referred as the skin effect in the transmission lines. So, the phenomena arising due to the unequal distribution of the current. As we know, the general tendency of the charge is to stay outside of a conductor. So current will be inside. The current is almost 0 and outside the current is the maximum. The phenomena arising due to the unequal distribution of current over the entire cross section of the conductor being used for the long distance power transmission is referred as the skin effect in the transmission line. Such a phenomena does not have much more role to play in case of a very short line. We will not get the skin effect for a short line, but with the increase in effective length of the conductor, skin effect increases considerably. So the modification in line calculation needs to be changed. The distribution of the current over the entire cross section of the conductor is quite uniform in case of DC system. But what we are using in present era of the power system engineering, predominantly an alternating current system, where the current tends to flow with higher density through the surface of the conductors. So this is known as the skin effect. Now we will discuss about the Ponting theorem. Next we will discuss about the Maxwell's equation in the time varying field. What is the Maxwell's equation in the time varying field? So in the Maxwell's equation we got the grad cross E is equal to minus dB by dt. Grad cross E, where B is the magnetic flux density. And what is E? E is nothing but the electric field intensity. So we got grad cross E is equal to minus del B by del T is equal to J omega B. Also we know that the grad cross E is equal to, we can again write B is equal to mu H. So grad cross E is equal to J omega mu H. So what is the grad cross H again? From the, this is we are getting from the Faraday's law. Next, grad cross H is equal to J plus d by dt, where J is equal to, what is J? J is the conduction current density. So grad cross E is equal to del D by del T. Actually it is JC, the displacement current density, and we can write. So grad cross H we got. So what is the J? J is equal to sigma E plus J omega D naught. How we are getting the J omega D naught? Actually it is a time varying field. So the equation of the flux, first is the E is equal to, if we take Em sin omega t, then D will be Dm sin omega t. So what is the d by dt? D by dt, or we can write d naught omega cos omega t. And what is the maximum value of this? The maximum value of d by dt is d naught omega. So it is also, if you take E naught cos sin omega, d naught omega. And as this is d by dt is equal to, then J is equal to sigma E, and it is J omega d naught omega. So we can write sigma E plus J omega epsilon into E. So E is equal to sigma plus J omega epsilon. Actually it should be the small j. Small j means the imaginary equations. So we got grad cross H is equal to J plus del dot del T is equal to sigma E of J omega D naught equals to sigma E J omega epsilon E. So if we take the E constant, we can write E is equal to sigma J omega epsilon. So what is the, if we take the both side integration, grad cross H ds is equal to integration of J plus dd by del T into ds. Again grad cross H can be written as the H dot dl is equal to integration of J plus del D by del T ds, and that can also be written as the sigma plus J omega epsilon integration of E ds, and this is the integral form of Faraday's EMF equation. This is the integral form of the Faraday's EMF equation. And now we will discuss about the next is the Ponting formula. Next is the Ponting formula. So what is the Ponting theorem? Now we will discuss about the Ponting theorem. What is the Ponting theorem? Ponting theorem states that the rate of energy transfer per unit volume from a region of space equals to the rate of work done on the charge distribution in the region plus the energy of the flux leaving the region. So what is this? What do you mean by the Ponting vector? Ponting vector tells, named after the John Henry Ponting, is used to order to demonstrate the energy flux density of an EM field. It will tells about the electromagnetic field. As per the definition of Ponting vector is the result of the vector product of the electric field and magnetic field components. So we write the Ponting theorem by P, or sometimes we write by S. P or S is a cross product of E cross H. It is a cross product of E cross H. So what is the Ponting theorem states? Ponting theorem states about the electromagnetic energy. We know electromagnetic energy transfer per unit volume from one region of space equal. So if we are talking in the mobile, so when we are talking in the mobile, the sound wave change into the electromagnetic wave, and it is going from the one space. From this space, it is going to the other region. So this energy, when we are talking to the one light energy, when the light energy is coming, the energy has been divided into two parts. First part about the rate of work done on the charge distribution, the amount of work done in the charge distribution, plus the energy of flux leaving the region or going to a new region. So Ponting theorem states that the rate of energy transfer per unit volume from a region of the space equals to the rate of work done on the charge distribution in the region plus the energy flux leaving the region. And the Ponting first told about a new vector, which vector is known as the Ponting vector. This Ponting vector named after John Henry Ponting. It is named after John Henry Ponting, is used in order to demonstrate the energy flux density of the EM field. What is the meaning of the energy flux density? Energy flux density can be rewritten from the energy flux per unit volume. We will calculate the energy flux in a unit volume, and as this is an electromagnetic wave, it will depends on the electrical wave plus magnetic wave. So the Ponting theorem, as per the definition of the Ponting vector, the vector is a product of the E cross H, and we write it by S, or we can write it by P. So P or S, you can write anything. We can write P is equal to E cross H or S equals to E cross H. What is E? E is nothing but the electric field intensity. What is H? H is nothing but the magnetic field intensity. So P dot S is equal to E cross H. And what is the direction of S? It is a cross product. The direction is always the perpendicular of the electromagnetic plane. If there is a plane where the electric field and the magnetic field superimposed, the H always works on it in the perpendicular way. So we generally write by S. S is equal to EH. The magnitude of the S is EH sin theta, and it will be maximum when theta is equal to 90 degree. Now we will discuss about the Laplace and Poisson's equation in the electrostatic field. Actually, I missed this topic before, so I will revisit here. We will get the first, what is Poisson's equation? Poisson's equation is grad square V is equal to minus rho epsilon square. What is rho? Rho is nothing but the volume, or rho V, better to write rho V, volume charge density. So it is the rho V by in epsilon. And for the Laplace equation is the little modification of the Poisson's equation, grad square V equals to 0. If any potential or any voltage field voltage field obeys this rule. We will tell this is the Laplace field. If any voltage has been use this rule, we can tell it the Poisson's field. So Poisson's equation states that the Laplacian of the electric potential at a point is equal to the ratio of the volume charge density to the absolute permittivity of the medium, not the all permittivity, the absolute permittivity of the medium. Laplace equation tells us the Laplacian of electric potential at a point is equals to 0. So we can prove this from the Gauss law. How we can prove this from the Gauss law? From the Gauss law, we can write grad dot E is equal to rho v into epsilon 0. We can write grad dot E is equal to rho v into epsilon 0. Now what is the relation between V and dl? The relation between the V dot dl is equal to V is equal to E dl, or dV is equal to minus E dl. So we can write dV by dl is equal to minus E, or grad dot V is equal to minus E. We can write grad dot V is equal to minus E. So if we take the grad in the both side, grad dot E, grad dot V is equal to, we can write grad dot minus of E, grad dot minus of E, or minus grad dot E. So we can write again grad square V is equal to minus grad dot E, we got already from the Gauss law, rho v by epsilon E. So this is the Poisson's equation. So how we can get the Poisson's equation? We know the potential E is equal to minus E by dl. So dV by dl is equal to E. So dV by dl means grad dot V is equal to minus E. Now if we take the grad in the both side, grad dot V is equal to minus of E, grad dot V is equal to grad dot E is equal to, we can write minus grad dot E. Now from the Gauss law, we can write grad dot E is equal to rho v by V naught. So this is the grad square V is equal to rho v into epsilon, and this is the Poisson's equation. Now, so Poisson's equation will be applicable in any medium. But if we think about the free space, in the free space, what will happen? Or inside any conductor, there is no charge, and there is no charge means rho v is equal, Q is equal to 0 means rho v equals to 0. And that time this equation will equals to the grad square V equals to 0. So this is the modified Poisson's equation, or we can tell it is the Laplace equation. So today in this my 3 lectures, I have discussed all the laws one by one of the electromagnetism, and thank you all.
Like, share and subscribe. Hit the bell icon for more updates.